Hi class. So today we're going to talk a little bit more about some special triangles and right triangles. And I wanted to start this with some discussion about the famous Pythagorean theorem that we've used all year, but I wanted to make sure that you see how to use it correctly, because when we have this, you need to remember that always the c squared, is the hypotenuse. They're always talking about the hypotenuse when they're talking about c. So if you look at, I think that's an S, I don't know, these three triangles, right? This is your c on this one, this is your c on this one, and this is your c on this one. The c is always directly across from the right angle. All right, so if we were wanting to find the x or the c value here, we would say 5 squared plus 10.3 squared is going to equal our c squared. So we would need to find, in order to find c, we would need to find the square root of these. 5 squared plus 10.3 squared. So whatever that is in the calculator, that would be your c. Now on this one, the middle problem, your c you already know. So that's our 11 squared equals 9 squared plus x squared. Now in this case, I'm making this the a and this the b. Okay, it doesn't matter if this is the a or this is the b. Whichever one you want. The legs, the labels of the legs don't matter. You just have to always remember that the hypotenuse is the c value. So in this case, then, we would get 11 squared minus 9 squared, and we would find the square root of that. So that's what, 121 minus 81. So I'm thinking that's the square root of 40. And a lot of times you'll see it say, show it in the exact form. The exact form means don't punch it in a calculator. It means simplify the square root of 40. So we'll do upside down division. 2 goes into their 20, 2 goes into their 10, 2 goes into their 5. So we've got one pair of 2's. So the square root of 4 is 2. And then we still have this 2 and 5 under our square root sign. So our simplified value for c would then, or I'm sorry, for x would then be 2 square root of 10. Okay, so if you need to stop the video and write this down, go ahead. But I want you to try 7. So if you want to stop the video and write it down and try 7, go ahead, and then we'll start the video back up and I'll show you the answer to 7. But right now you need to make sure you've got in your notes, at the very minimum, a picture of a right triangle and where you specify what is the hypotenuse and what the other two legs are. All right, so after you have turned the video back on, welcome back. And if we look at this again, we're starting with a squared plus b squared equals c squared. Our c is our hypotenuse, so that has to go over here. And then either one of these can be a or b. I always just put the one first and then b squared, okay? Because then I know I'm going to subtract my 9 squared. So I have b squared equals this 16 squared minus 9 squared, okay? And then we can just take the square root of both sides, which gives us b equals whatever this number comes out to, all right? So you would take 16 squared, subtract 81 from it, and take the square root. So that's just a little overview and a little reminder of Pythagorean theorem. So always be conscious of which side of the triangle you're looking for, okay? So we're going to continue into special right triangles. These are triangles that have these specific angles, 30, 60, 90, and 45, 45, 90. You did a little discovery with that on the calculators in class, and so hopefully this will clear those up a little bit and you can see what you were looking at on the calculator and why it is. So in a 45, 45, 90 triangle, the hypotenuse, so again, the longest side is the hypotenuse, okay? And it's across from the 90-degree angle, and it's always the square root of 2, times the length of the leg. The legs are always going to be the same length, okay? And so for a 45, 45, 90, so then that makes this hypotenuse x times the square root of 2. And it's always going to be that way. So if you take a look at this, it'll kind of show you why. If you have a square, okay, and you take the diagonal, well, you've got a 90-degree angle here. You've taken the diagonal, so you've bisected these angles. They're going to be 45 degrees. Okay, so that gives us a 45, 45, 90 triangle. It's a square, so both of the sides are the same. So if you use Pythagorean theorem, you have x squared plus x squared equals d squared. All right, so you basically have 2x squared equals d squared. So if you wanted to find the value of d, you're going to take the square root. So you're going to take the square root of 2x squared. Well, if you split that up, you've got the square root of x squared times the square root of 2. Square root of 2 is going to stay the same. Square root of x squared is x. So x square root of 2. So your hypotenuse is, again, the square root of 2 times the side of x. So we've kind of proven it using Pythagorean theorem. If you want to see that a little more detailed, then just stop the video and take a look at what's under this bar, and there's your, that's the same thing kind of written out for you. All right? So let me put that up there. If you wanted to pause it, you could write that down. This would be the proof of that shows that right triangle 45, 45, 90 is always going to be the hypotenuse is the side times the square root of 2. All right? You want to be sure to get this down in your notes because it could be one of the questions on your quiz. All right, so let's do an example. So we have this again, a right triangle. Here's our hypotenuse. We've given one side, but it tells us that this angle is 45, which tells us this angle is 45, because 90 has to have this 90 to make 180. So if we know that this side is 18, what do you think this side is? Hopefully you're going to say 18. And since it's a 45, 45, 90 triangle, if you look back in what we said, the y has to be the side times the square root of 2. So if you can see that, you can understand why knowing these relationships is so important, because otherwise you would have had to said, well, 18 squared plus 18 squared has to equal y. So now we have 2 times 18 squared, right, equals y. And if we take the square root of that, equals y squared, I should say. If you take the square root of that, y equals 18 is going to come out because it's got 2 of them, and the square root of 2 is left. All right? So you can do that math because it's a 45, 45, 90 triangle. You can use Pythagorean theorem right here. That's what I'm doing. Or you can recognize the relationship between the 45, 40, 90 triangle and just know that that's the answer. All right? So let's try one more before we go on. So again, here's our right triangle. This is now our c squared, right? Or our c, I should say, not really c squared until we put it into the equation. And this is a 45, so that makes this a 45. So this is 8. What does that make y? It would also be 8. And the x, because we know the hypotenuse on a 45, 45, 90 is the leg 8 times the square root of 2. And we're done. All right, so recognizing these values is very important. Now, the other special relationship that we've talked about, or that we've kind of looked at, is the 30, 60, 90 triangle. Now, the altitude is drawn from any vertex of an equilateral triangle, then the triangle is two congruent 30, 60, 90 triangles. So if you take a look at that, we could derive it with Pythagorean theorem. But basically what it's saying is that if this is a 30, 60, 90 triangle, if this is an equilateral triangle, then each one of these sides are the same distance, and each one of these angles, the full angle, would also be the same distance. And when you bisect the side at the midpoint, you're bisecting the angles, and that gives you your 30, 60, 90 triangle. All right? So if you wanted to use Pythagorean theorem, you'd have to remember that this side is equal to 1/2 of x. All right? And see, you know this is x, and this is your unknown, because you know this side is equilateral triangle. So if you wrote it as a squared plus b squared equals c squared, right? So your a is still here, so we're going to leave the a. We're going to make this 1/2 x squared, and then this is x squared. All right? So if you would do this, you would combine your terms. You have a squared. This would be plus 1/4 x squared, because 1/2 times 1/2 is 1/4. And so you would have to subtract this, okay? Equals, so that would give us 3/4 x squared equals a squared. All right? Sorry, my dogs are barking. So then we're going to take the square root of both sides, and we have a equal to the square. I'm going to separate these because we have some perfect squares there that we can deal with, right? So we're going to say the square root of 3 has to stay, but the square root of x squared is x, and the square root of 4 is 2. So that means this side is the square root of 3 over 2x. Now, what we want to look at is 1/2 x is our short side. So what we really have here is the square root of 3 times 1/2 x, or the square root of 3 times whatever your short side is. Okay? And your hypotenuse, if it's x and our short side, we want to kind of look for a relationship. If our short side is 1/2 x, our hypotenuse is 2 times 1/2 x, or x. So if you're looking for the relationship for a 30, 60, 90 triangle, let me get a triangle here right quick. It's probably more of a, we're going to pretend that's a 30, 60, 90 because that's what I can draw fast. We're going to say this is our 30 and this is our 60, right? And this is our 90. So if we look at our relationships up here, our short side is across from the 30, right? Our short side is across from the 30. So if we let the short side across from the 30, okay, short side, because it's across from the smaller angle, let's let that equal x, okay? Our long side was 2 times our short side, okay? So our oops, that's our hypotenuse, my bad. Our hypotenuse is 2 times our short side. So in this case, it's 2 times x. And then our long side is across from our 60, right? So this is our long side. And if we look at our picture up here, our long side, which was here, was the square root of 3 times the short side. So in this case, our short side is x, square root of 3 times x. Or you write it x square root of 3, okay? So this is our relationship that we want to always remember. Across from the short side is your x value. Across from the long side is your x square root of 3, or the short side times the square root of 3. And then our hypotenuse is always twice the short side. So that's what's written right here. I think it's better on the next page. So if you take a look at this angle, this is what we did, all right? So I want to look at, here we go. This is what you want to write down. Make sure you have this written down. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg, and the longer leg is square root of 3 times as long as the short leg. So that's the relationship that you're looking for, and here it is in the picture. Again, here's your 30. Let me do that with a different color. There's your 30 is your short side. It's across from the 30-degree angle. The 60 here is your long side. That's the one that's across from the 60-degree angle. And the 90 degrees, that's always your hypotenuse. All right? So this is the relationship that you want to remember for a 30, 60, 90 triangle. So let's see if we can try one. Okay, here's your picture. If you want to do a picture, stop the video and copy this down. This would be the picture for 30, 60, 90. So you were given a foldable. This would be the picture that goes in that foldable. You can go back to the 45, 45, 90s and do the same thing. A picture and your notes need to be in that foldable. All right, so here's an example. It's a regular hexagon. It has 6 equilateral triangles. So if you find AC, this length here, right, it's bisecting this side of the hexagon. So that makes this your 30 degree, and that makes this your 60, and this is your 90. All right? So if we know that one side, this side, has to be 10, because it's equilateral, right? So this has to be 10. And this is half, because it's the midpoint. It told us it was the midpoint. This has to be 5. Okay? So if you take a look at your 30, 60, 90, so let's kind of just draw this. Here's the way it would look, right? So this is 30. This is 60. This is 90. And this is 10. And this is 5, which makes sense because our long side is 2 times our short side. Not our long side, I'm sorry. The hypotenuse is 2 times the short side. Our long side across from the 60 is the square root of 3 times the short side. And how much was the short side? Right, it's 5. So this would be AC would be this, or I'm sorry, AD to the center would be the square root of 3 times 5. Now, that's half. We need to multiply that by 2 because the 5 square root of 3 would also be this distance because it's regular and they're all the same. So if you want the line AC, the measure, it's going to be 2 of our 5 square roots of 3. So that would make it 10 square root of 3. All right? So that's one example. You might want to pause and write that down. Here's another example. Oh, actually, that's that one worked out. So if you want to see this one worked out, you can pause and write that out. That would be how it was worked out. Here's another example, kind of a quick one. Now we're going to figure out which one is it. Is this a 45, 45, 90, or is this a 30, 60, 90? Well, what's your first clue? The 45. So this has to be a 45, 45, 90, which means if this side is 8, what is this side? That's right, it's also 8, and this side would be 8 square root of 2. Okay? Let's look at this one. Again, 45, 45, 90. This time, though, they're only giving you the hypotenuse. So you have to remember that the hypotenuse is the leg times the square root of 2. So if I look at this, 9 square root of 2, that means the leg is what? That's right, the leg is 9. Okay? So if this tells us the leg is 9, then what are these other values? X is 9 and Y is, that's right, 9. All right? So if you have a different number here, say you had 10 here, okay? 10 does not have a square root of 2. But you know it's a 45, 45, 90. What you would do is you would set 10 equal to x square root of 2. All right, and you would have to divide by square root of 2. You would have to rationalize, you would have to rationalize the denominator, okay, so that you get a square root of 2 on top. So if you don't remember how to do that, that means you have to multiply 10 over square root of 2 equals x. We have to multiply this, okay, so that we get it becomes square root of 2 times square root of 2 is just 2 over 10 square root of 2. So that means 10 divided by 2 is 5, right? Square root of 2. So then our leg would then be, x would then be this, 5 square root of 2. Okay? So this is just an example. If your hypotenuse is not given to you in the form of 9 square root of 2, you have to set that equal to the x square root of 2 in order to solve for x. So that may be one we do in class, but that's something like a question on the quiz could be, what do you need to set the hypotenuse equal to in order to solve if the side was 10, if the hypotenuse was 10. So think about that. And then this one, again, what triangle is this? 30, 60, 90. And the side opposite the 30 is our short side, right? And the side opposite the 90 is 2 times the short side. And the side opposite, this has to be the 60, is the square root of 3 times the short side. Okay? So, the short side is x. We don't know that. But we know that 2 times x has to equal 10. So that means that x equals 5. All right? So that would be, yep, there we go, 5. And if x is 5, then we know here that y has to be 5 times the square root of 3. And there we go. All right? So you just have to figure out which side you have and then work backwards from there. Let's do one more of these. Again, the side opposite the 30 is the short side. So this is our short side. The hypotenuse is 2 times the short side. So if our short side is 9, it's 2 times 9, or 18. And then this is our 60. So this has to be the short side times the square root of 3. Or 9 square root of 3. So let's check those. There we go, and there we go. All right? And that is our lesson for today. So in class, we're going to work on some more of these with applications, but make sure on your foldable, you got the notes, because I gave you a piece of paper to put in your workbooks, and they should be the 2, right? 2, and one's a 45, 45, 90, and one's a 30, 60, 90, and you should have got a picture for both. Like a definition or how you recognize it, and then an example. So pick one of the examples and make sure you get it written in your notes. I'll be collecting the notebooks at the end of the week, so that means for B day it'll be Thursday, and for A day it'll be Friday. All right. And you also should be able to answer to do any of those examples that I've given you. You should be able to redo them in your on your quiz. So you need to make sure that you have them written down or understand them, so that if I put them up on the quiz, you can answer them. All right? I will see you in class. Be sure to do the survey at the end of the video. It's on the Google